Okay, so I'm on to number 4 here. We're still on assignment 2.5, and we're just going through a bunch of proofs. So here is an unusual proof in which we're going to actually prove one of our properties or theorems. So it's important to remember, whenever I'm actually proving a property or a theorem, I can't use that property or theorem in the proof. If I could, the symmetric property just says if A is congruent to B, then B is congruent to A. Well, I could do that. BQ is congruent to XY, then segment XY is congruent to PQ. I wouldn't need to do anything if I was able to use this proof. Of course, the tough thing here is that I can't use it. So I'm looking at my diagram. We find out that PQ is congruent to XY. If they're congruent, that means they have the same length. All right, and then once they're the same length, we're talking numbers. That's properties of equality. So again, I can start off most proofs, or a lot of them anyway, by just restating the given. So segment PQ is congruent to segment XY, and that's a given. And if I can say this, then I can say length PQ is equal to length XY. Okay, these are numbers now, and that's just definition of congruent segments. And if the lengths are equal, this is an equality. The equality, I can use a symmetric property because that's not what I'm trying to prove. So length XY is equal to, if PQ is equal to XY, then XY has to be equal to PQ, and that's just a symmetric property of equality. Now notice these do look the same. Symmetric property of equality. This is a symmetric property of congruence. Okay, so I can't use the congruence, I can use the equality. And once I have this, this is easy to convert back into my segment statement. So segment XY is congruent to segment PQ, and that's just the definition of congruent segments. And that's the end of my proof. Number 5, looking at my diagram, looking at my given. LK is 5 and JK is 5. And furthermore, segment JK is congruent to segment JL. What I want to prove is that LK and JL are congruent. Alright, so let's start by stating our given. Length LK is 5, length JK is 5, and segment JK is congruent to segment JL. Given. This is another one of those times you really have to practice your attention to detail to make sure that you're keeping all these letters straight. Usually something I have trouble with myself. So I can come down here. These are equal to the same length. These are both equal to 5. That means they're equal to each other. So I could say that length LK equals length JK. And that's because of the transitive property of equality. If A is equal to B and B is equal to C, then A is equal to C. Okay, and if they're equal in length, then we can say that those segments are congruent. And that's just the definition of congruent segments. And if these segments are congruent, I better make that segments. I also have the transitive property of congruence I can use. So that says if A is congruent to B and B is congruent to C, then A is congruent to C. So there we've got that one, and that's our final line for this one. So LK is congruent to JL, and that's the transitive property of congruence. On to number 6. Oh, a midpoint one. So Q is the midpoint of PR. So midpoints divide a segment or an angle in half, or midpoints divide a segment in half. And that means that this is equal to this. We've also got a segment, so we've got maybe segment addition postulate. So let's go ahead and see what we've got here. So let's start with our given. Q is midpoint of segment PR, and that's given. And since a midpoint, let me look up the definition. Do midpoints bisect? I don't remember. So I'm looking up the definition here. Midpoint, the point that divides or bisects a segment into two congruent segments. So if this is the midpoint, by definition, I can say that these are congruent. So PQ is congruent to QR. That's just the definition of midpoint. And if that's true, we can say that PQ, length PQ equals length QR. That's the definition of congruent segments. Alright, somehow I've got to get some half and everything going here. How about we try the angle addition postulate? PR equals, so length PR equals length PQ plus length QR. That's just segment addition postulate. And let me see, there's PR we can substitute in here, so I could say that, whoops, length PR equals, let's substitute in QR, equals QR plus QR, or PR equals 2 lengths of QR. If I divide both sides by 2, or multiply both sides by 1/2, I get 1/2 PR equals QR. And then I can swap those around. So we'll need a step 8. QR equals 1/2 PR. Said I had to prove two things here though. So there's my QR. To get my PQ, I can just substitute in QR. I can substitute in PQ for QR. So I can also say PQ equals to 1/2 PR. So I need to fill in my reasons here. So PR, why does this equal? Okay, so I did segment addition postulate. This is substitution property. And this is combine like terms. And this is the multiplication property. And this is the symmetric property. And this is the substitution property of equality. Alright, so there's a couple more proofs, and check out the next video and I'll keep going.